first slide, and you should see a full screen presentation. Everybody happy with that?
Yes, that's great.
Okay, so you can see the title of the talk on my screen. For the last year or so, I've been experimenting with the SharpCap sequencer to see if I could fully automate a night of occultations. And so far, it's been going very smoothly, very well with a variety of telescopes. And I wanted to share with you my experience, some of those techniques, and certainly field as many questions as I can and open myself in the long run to any questions you might have if you want to try to do this yourself. So I'm going to start with a disclaimer, which is I know there are plenty of you who are already out there running full night automated occultation observations with very sophisticated systems. And this is just one other path. I did want to talk about it because I found it to be a relatively easy path. So, if it's something that you're interested in getting into and you aren't doing this sort of thing, this is I think, a great entry point to, automating observations. What got me here, in part, was Ted Blank, who I saw smiling when I was getting set up here. In that about 6 or 7 months ago, I hauled a bunch of your mid-sized mini systems off to Spain to do an observation of clouds. More than anything else, it was actually a rather broad campaign to observe Euripides. And I was quite enamored with the whole setup there of being able to do a automated video recording to pre-point a system, which is, you see one of your systems on the left, all ready to go, pre-pointed and ready to be abandoned. And my long-term interest has been using framing cameras, integrating cameras, so SCMOS imagers in particular, and doing the same thing. And at the point where I was using your mini systems, I really didn't know about the sequencer, but was very curious about ways that you could abandon, pre-point and abandon a framing camera in the field and get the same sort of result. And on the right is my equivalent, which I call the Mikey Mini, given my first name, which is just the same thing, but with a QHY-174 GPS on the back end. And this happened to be a tended observation, but the whole idea was to evolve to a point where a telescope, particularly a go-to telescope, could do this all by itself. And so, as I said, I'm going to focus on using this SharpCap sequencer as an approach to this, just to make sure everybody's on the same page. SharpCap is a free Windows application that allows you to acquire rapid frame cadences, save them, and store them as FIT files or whatever you want, SER files. And it happens that the person who wrote this software has included a scripting language of his own in the package. It's called the sequencer, although you can also write Python-based scripting, but I haven't gone that route yet. And the only disclaimer I'll make is that more than being free, you have to pay $15 to unlock annually to unlock the features like auto-focusing and auto-scaling of images in the scripting language itself. So it's not quite free if you want to go this route. The green lines that follow here really show you, I think, in a nutshell, what you can do. So these are, some of the actual scripting commands, but they encompass everything you would need to do to automatically get your telescope on field and taking data. So, the first line, mount go to, gets you to a coordinate on the sky. Whether or not it's the right coordinate or not, when you actually get there, is the second line, which does plate solve and syncs the telescope to your new coordinates. Very useful. Obviously, you're going to want to automatically set your exposure time. You're going to want to capture a bunch of frames, and you'd like your images to be in focus to maximize sensitivity. The scripting language allows you to do all those things. And of course, for occultations, timing is important. So presuming your system has the right time, and SharpCap is importing the GPS determined time from the QHY-174 GPS. There are commands which essentially can gate your observations, gate every step of the procedure to the right time. And that's really the key to completing a full night of observations. This is a blurry slide. I just grabbed a picture of the sequence editor just to show you, and let's see if my cursor's there. You might be able to see my cursor. There is a line right at the top that opens the menu to get into sequencer commands, where you can either edit a sequence, you can run a sequence. I've actually brought up the sequence editor, which is pretty sophisticated. Basically, you can search for commands. So if you want to look for capturing commands, you just type the word capture up here. Then you drag and drop from over here the command into a sequence, and you actually see the sequence being built with the text sequence commands down here. When I started, I was playing with this editor because it was an easy way to put a sequence together, but it didn't take long to just start looking at the raw sequencing commands and realizing that you could just go and construct a sequencing script that would get you through a night of observations. And as I alluded to before, it's a pretty obvious recipe here. In fact, the whole concept is built around turn on the telescope, run the script, walk away, and you're done. And so this would apply to either acquiring a single occultation observation of an interesting target. When we were doing preliminary in Kansas back in February, I was actually using sequences to get the telescope set up because I just didn't want to bother with alignment. And what I'm about to show you will put the occultation star in the center of the field by itself with no intervention from you, assuming no extraneous terrible conditions. So the steps, as it shows on the slide, you start with just a crude alignment of the telescope. Skywatcher telescopes, for example, are set up so when you power them up, they're expecting you to be pointed at the north horizon, due north. And so the paddle will come up with coordinates consistent with north and level on the horizon. I have a Hubble optics telescope right now, and I use the park position for that telescope. Even though I don't have a fixed observatory with that telescope, I just carry it outside every night and set it down somewhere. Still, the park position is what I use is altitude 55 degrees, azimuth 180. It's easy enough to push that telescope around until it is within a degree or two of that, and that's all it takes. And to be honest, I don't think I wrote it down, but SharpCap's plate solving searches a 15-degree radius around the coordinate you think you're at, and so you would have to be pretty darn mispointed not to be able to do a plate solve update of your telescope coordinates. So bottom line, point the telescope in a known orientation that the paddle or the control system is going to know when you turn it on, and then make an attempt to get to your target, slew to target, next item, which is just using that mount go to command. You're going to miss because you lined up the telescope by hand to within a few degrees. I usually hit about a degree away from where it's supposed to be just by doing this. But the whole point is your next step, plate solve, is going to take the star field. It's going to determine where the center of that field is. It's going to update the telescope coordinates to the pointing of the telescope. And now your uncertainty in pointing is down at the arc minute level or so. And so, as I say, in the next line, you iterate the pointing. You're going to slew again, move that 1 to 2 degrees you were off, plate solve again. So you're refining the paddle solution for the telescope. And then, slew one more time to make up that last arc minute or two, and your star's dead center. You probably didn't even have to do that last step, but I always like to, over iterate just to be sure I'm there. As I mentioned, focus is important. So you command the telescope to focus at that point. I'll talk about focusers in a second, because a lot of times telescopes don't have convenient focus drives that interface well, but there's an easy way to address that problem. And then you sit and wait until event time comes. And once that time comes, 2 minutes before the event is what I typically use. So I do a 4-minute observation of any occultation. So 2 minutes before the event, I let things go. I do one last plate solve and sync and point just to make sure the star jumps right to the center of the field. And then set the frame rate to whatever it needs to be for the event and take the appropriate number of frames, capture that number of frames. You're done. Move on to the next target. Do it all again. And typically nowadays, I'm doing between 6 and 12 events in a night. And I'll talk more about how you come up with those events that are relevant from your back porch. I mean, the other message here is everything that I'm talking about happens on my back patio, and there's no running around trying to get into shadows. But it's a very different type of event that you're chasing after, but a productive one, I think. I'll try to convince you of that in a second. So what do you need to do this? Obviously, everything is under computer control, and your mount, your focuser has to be responsive. You've got to have plate solving software. And so hardware-wise, you've got to have a go-to telescope mount, right? Because the telescope is driving itself to position. These components have to be ASCOM compatible because SharpCap is expecting to talk to ASCOM components. Just about anything astronomical is. If you're not familiar with ASCOM, it's a wrapper for just about any technology associated with a telescope. The drives, the focus mechanism, rotators, you name it. Any of these things are set up so they can be transparently controlled, right? Every focuser in the world has a very natural command set. Go to this focus, move the focus by 200 units, in the negative direction, move another 200 units in the negative direction. Those are very universal commands. What ASCOM does is it makes those commands absolutely transparent to the hardware. So there can be 20 different focusers in the world, and there are, but they're all controlled by the same command set. They're all controlled by the same command interface. And this is built in to SharpCap. So SharpCap is set up to run your focuser. It's set up to run your telescope. And you just have to make sure it's configured the right way, which I'll show you in a second. So that's the hardware aspect. The software aspect is that you need to be able to plate solve. There are two free plate solving algorithms. Actually, there's a number of implementations. These are, I think, the two most popular. One is called All Sky Plate Solver, ASPS. The other is called the Astrometric Stacking Program, because it's really designed to get the astrometric solution so that you can take many shorter exposures and build up, a really wonderful deep sky picture, but it's a great plate solver on top of everything else. So you need to just install those things and have the associated stellar databases so they can actually figure out where you're pointed on the sky. Once again, SharpCap naturally interfaces to these programs. So these are just part of the pull down menu in SharpCap. Which plate solver do you want to use? There's even a button in SharpCap. You push it and it initiates a plate solve, updates your telescope coordinates if you're really working by hand. Here, everything is automated. Of course, you need a camera that SharpCap can talk to. I don't know of a camera that SharpCap can't talk to. Even the run cams that you use for video, SharpCap will acquire images, and you can even plate solve with SharpCap using run cams, because I was playing around with that when I was using your mini systems. And then, of course, all of this is being run by some computer somewhere that's interfacing to your telescope. So you've got to bolt some small computer, a stick PC. I use a B-Link PC, so you see that pictured rubber banded to my Hubble Optics telescope over here, which connects to my focuser, connects to the mount control, does all the talking. And then, of course, in that case, in all these cases, you need some remote desktop software. I won't go into the details there. I'm using No Machine right now, if you've heard of that. But the wonderful thing is you pop your laptop open in the house, you connect to the telescope outside in the cold, and wherever you are, you can run your system and check up on it. And honestly, the procedure here is largely just to watch what's happening, make sure something crazy isn't happening at all, check in on the system once in a while. I don't actually do any manipulation of the system once the script is running. So I said, the focuser might be the most mysterious part of this system to many people, or maybe seem like a big hurdle. You don't really need a focuser if your focus is relatively stable with temperature. And I've done a lot of observations where I haven't had a focuser running, and the telescope hasn't gotten that out of focus during the night. It really depends on how much the temperature changes. But I did want to advertise what I use now, which is do-it-yourself ASCOM compatible focuser called MyFP2. Do a Google search on MyFP2. You'll find more than you want to know about it. In fact, there's so much that it helps to have a little guidance of, what board do I need to fabricate and what system do I need to put together to make this work, because it has many, many branches. But in the simplest terms, this is a Arduino Nano based focuser with all the necessary drivers to be ASCOM compatible provided. It drives a stepper motor. So, the focuser is nothing but a stepper motor driver. It's up to you to come up with some interface to get from the stepper motor to your focus knob. So on the right, you see my Skywatcher interface where I put all this stuff on a piece of oak and I banded it. I just Velcro stretch banded it to the telescope. And there is a timing belt and there is a timing belt matched to gear on the stepper motor. And I actually on the Skywatcher just let this belt grab onto the rubber of the focus knob, and there's no backlash in this system. It works very nice. This is the top of my Hubble Optics telescope. There's a nice 3D printed mount for the stepper motor. You see the belt drive just going around the Crayford focuser for that particular telescope. Now, again, works beautifully, very little backlash. And so there is a route to automating your focus, but it does require a little soldering and a little assembly at the telescope end. I'll mention that I had 75 of these boards made when I got into this building your own focus project. It was as cheap to make 75 as it was to make 5, essentially. So if somebody's interested in getting a hold of one of these boards, I can give you a board and some guidance on how to put your own focuser together. But don't let the focuser be a hurdle here. Plate solving. I hope most of you are familiar with using these plate solving programs. As people say, you'll never miss your finder after you start learning plate solving, because it does everything your finder really is needed to do for you. You never manually star align your telescope again. I make sure I have an Altaz, I always have Altaz telescopes. They're always level. Once they're level, as long as you get a 1-point solution, you're fine. But I think the interesting thing about plate solving is that even for a sloppy system, I could have my telescope 5 degrees off level. I go to my field, I miss by a degree. Well, I push the plate solve button, it updates the coordinates, go to the field again. Maybe I miss by an arc minute now. It's successive approximation and refinement. Plate solving just makes up for a multitude of sins. And so, you don't need a finder. I haven't used a finder in 3 years. Maybe once because I was trying to do a twilight event where I really had to align on bright stars. That's pretty much the only time I've had that out. These plate solving programs are pretty darn fast. ASPS always solves within about 3 to 5 seconds, except when there's a very dense field, and then it can slow down and maybe take 20 or 30 seconds. ASTAP is really fast. That is an instantaneous solver. I can't even see how long it takes, less than a second. The difference is ASPS seems to be able to solve with no problem on about 6 to 8 detected stars, and ASTAP really wants to have about 20 or 30 stars. And since reliability is key here, you don't want your plate solve to fail because you don't get your event. I've defaulted recently to using ASPS as my primary plate solver. You just tell SharpCap that's what you're going to use, ASPS, and it will consult that plate solver whenever you ask it to, either by pushing the button on the screen or with a command that I showed you before, the plate solve command. All right, this is very wordy, but I did want to show you what the script itself will look like in the end. So this is kind of the real thing. You see the word sequence on the top at the right. And I do the setup of my sequences with a bunch of subroutines. You can actually, it's a subroutining language, so you can write subroutines to simplify the text later on in the sequence. So I have a preamble of subroutines. The top one is a subroutine that does plate solving. The problem, it's not really a problem, but the nature of the SharpCap sequencer is if it throws an error on something, it kicks you out of the sequence. If you're set up to do 10 occultations in a night and the first occultation throws an error and kicks you out of the sequence, you've lost the rest of the night if you've gone to bed. I get more sleep because of this. That's the honest reason I've been pursuing all of this sequencing in the end. So you'll see a lot of commands like ignore errors from, so that if this particular step throws an error, and a failure to plate solve throws an error. So if the cloud comes by, the plate solve doesn't solve, that's an error. So you want to make sure it ignores errors. So that's what all this ignore error is about. I built into this subroutine, try plate solving up to 3 times total. If if at first you don't succeed, you try again twice. And so that's what that little subroutine does. So now I just say, go sub plate solve, and it does all this, and I don't need all this verbosity in my main script. The same with going to a spot on the sky. There can be slewing errors or something, rarely encountered, but there can be. So I embed this go to whatever coordinate command in an ignore error loop. I like it to put a settling delay at the end, although you can do that within the SharpCap configuration as well. And for each occultation during the night, I just have one of these little subroutines set up. I don't type all this stuff, right? I have a default script that has all these lines in it, and then for each night, I update the coordinates and update the various integration times and things. So there's actually little changes, and someday when I get smart enough, I will take the output from occult 4, pick my occultations, and write a routine that will populate this script with the right RA and DEC in all the right locations. And I'm sure people like Bill Hanna already do something like this, who run these magnificent automated enterprises out there. But right now I'm just learning to crawl with this stuff. So I have only the most rudimentary scripting for the night. I basically pick my sources, type the coordinates in, set up the occultation times, and then let it go. This is the rest of the single occultation part of the script, or the first occultation. So basically what I have it do is sit with the tracking off until 10 minutes before the event, right? You don't want the telescope slewing to position 2 hours before the event when your source may be below the horizon. I don't want to be picking my primary up off the ground. And so I think 10 minutes is plenty enough time to go through all the housekeeping to get ready for the event. So after, once you get within 10 minutes, so for this event, 419 UT, you go to the first pointing, go sub point 1. Once you get there, you plate solve. Once your plate solve succeeds, that's when I focus. So I call my focus subroutine, which basically just steps through the focus and does a parabolic fit. That's all pre-programmed into SharpCap. It just does it. After the focus, I'll do another pointing, do another plate solve just to make sure my coordinates are refined, and then tell the system to sit on its hands until 2 minutes and before the occultation. And then once the occultation time comes, oh, that's interesting. Are you seeing less than my whole, sorry about that. Oh, and I just started scrolling through stuff. Get back to where I was. There we go. All right, this is continuing on from there, I think. Yes. All right, so here we are at 4:29, 2 minutes before the event. One more plate solve. It doesn't take long, and to me, it's worth it to do that last check on coordinates. It's actually fun when you know the field, because if you're watching what's happening, it's probably running, in this case, at 4 hertz or maybe even faster. And if you know the field, you have a spider chart with you, this last step, you watch that star pop from wherever it is, a little off center to dead center when it starts acquiring occultation observations. So for this event, I was doing 4 hertz, and I took 1,000 frames. That adds up to 4 minutes. And basically, you've gone through, observing one complete occultation at that location at that time. One thing I didn't mention, it's mentioned over here, there is a unlock controls command. So the minute a sequence starts running, you're locked out of doing anything with pushing buttons within SharpCap. So you see the SharpCap screen, and all the buttons are inaccessible to you. You cannot pan the telescope. You cannot change the integration time. You can't adjust the focus. You can fix all that by embedding whatever's happening in this unlock controls and unlock procedure. And so while it's capturing data, I can still make tweaks if I really want to. So that's a very useful thing.
You got time for a quick question, Mike?
Please, anytime. Yeah, please interrupt me. I know I talked too much.
How sensitive are the plate solving software routines to focus? Because I noticed that after some hours out in the cold, you did some plate solves without, I didn't notice, maybe you did, without auto focusing. And so the stars might be all fuzzy and the plate solver might go crazy.
No, you're absolutely right. So there are two things about the focusing and the drifting of the focus. Absolutely, if you're too far out of focus, plate solve will have a hard time recognizing stars and you get into trouble. So I think there it's a matter of getting used to your system and how much the focus can drift and keeping that under control. For me, and the time, so I'm doing 10 occultations in a night. It's usually a half an hour to an hour at most between occultations. So it's not a lot of time for focus to drift. So beginning of the night, I make sure manually I'm in good focus by just pushing the buttons on the sharp cap screen to adjust to a good focus. And then, honestly, occasionally, if there's a very high profile occultation, high probability or so, I'll wake up in the middle of the night and just look to make sure it's close enough. But yes, if you are concerned that you're going to drift so far that the plate solve is going to have a challenge, you might focus first before plate solving, and you might even do a second focus after plate solving or whatever, just to refine the focus. And I can tell you a long story of woe and intrigue about using the autofocus with sharp cap. I think Robin is still refining the autofocus routine, and it's still got a lot of quirks, and it has a tendency not to solve. And especially if your starting point is off to one side of focus, there's supposed to be a smart focus algorithm. And for a while, that smart focus algorithm was running away, so I turned it off. The smart focus was going to recognize you're way off on one side of focus, and it's going to try to get you back to where you belong. So to me, you're absolutely right. That's the tricky part of this whole business. The getting a nice sharp focus, which for doing very faint occultations, something you absolutely need. You need it for the plate solving, and so that's my daily grind. Really, that's where I'm at in exploring this whole scripting thing is what it's really taking to get a good focus. And I've got a couple of other challenges. My mount is pretty sensitive to wind. I live in the Colorado mountains right now, and so there is a lot of wind occasionally. Hard to get an autofocus routine to reliably measure PSF size from step to step. And that's why, in large part, I think the routine has a hard time coming up with parabolic focus. I'm going to ask Robin to put in a feature where you have the option to say, go back to the best focus after going through a scan, even if there's no parabolic fit. I think that'll get me into less trouble than it always going back. When it fails, it always just goes back to where it started, which is logical, but may not be where you want to be. So, that's a great discussion to have, and I wish I had a more definitive answer. Those of you who have more stable mounts, who have more reliable control over the focus, may do a lot better with this autofocus routine. So, it's figure it out once you start running these scripts. See where it fails. That's the story of my life right now. Is run the scripts. Oh, it had a problem on that particular star, and you go back and try and reverse engineer what went wrong and try to prevent that from happening the right time or the next time.
Can I ask another quick question?
Yeah, jump right in.
Setting exposure, I suppose that's similar. You kind of have to figure out what your exposure needs to be for the plate solve.
Exactly. Well, for the plate solve, yeah. And so I typically set up a default exposure time in 2 seconds, and that seems to get me enough stars for plate solve, even in sparse fields, that I get a solution all the time. Okay. And so that's another thing you want to explore is what that best initial integration time is going into plate solve.
And one other question that you may or may not plan to address later with ASPS, are you offline?
Yes.
Solving?
Yes. So okay. You have all the databases.
Yeah, I eventually know what databases you use, but that doesn't have to be verbally now. That could maybe that's part of your documentation.
Yeah, thanks. Well, I can, yeah. So ASPS has a widget or something. I think it's called a wizard that allows you to download the databases you need for your focal length and your pixel size and your array format. And so you go to ASPS wizard and put in your parameters and download the databases it tells you to, and so that's entirely offline plate solving. And the same is true for ASTAP. There's a database of quads for that too that you download. You're all set. All right. So another caveat, or not caveat, but actually feature of ASCOM, of course, as I said, it's device independent. It's just something that it makes all commands universal to all systems. So the 5 systems on the bottom of the screen will work with the same script. no changes except in sharp cap. You have to say, I'm using a Hubble optics telescope, or I'm using a celestron, or I'm using an ioptron. But those drivers all interface with ASCOM, they interface with sharp cap. So any one of these systems can operate transparently with the same script. Same script, different night, I guess is what I'm saying. This is the menu in sharp cap settings, left-hand side at the top under File. And I just want to show you. So I dialed in here under select hardware for mount, Skywatcher telescope, focuser, my FP2 ASCOM, and off you go. It is otherwise transparent to those pieces of hardware. While I'm talking about the configuration, there's also a plate solving tab in the sharp cap configuration. So it happens here, I have ASCAP selected, and then it also asks you to select what you're going to do when you get a solution. I like to only sync the mount and save moving the telescope for my own command later. You will get much faster plate solves if you pre-populate the right focal length for your telescope. And I think it runs faster if it works on 8-bit images. So I always check that box. But anyway, that's how you configure plate solving for sharp cap. And then once configured like that, you've got the button where you can always initiate a plate solve manually. And there's in the script that plate solving command. So that's the general scripting procedure. I want to talk about, is this useful? Can I sit at home with an 8-inch telescope and actually find 10 useful occultations to do in a night? And the answer is basically yes. It takes a bit of work. It takes a bit of patience. But my rate of success having an 8-inch telescope always in the same spot on Earth on my patio is that I get about 1 positive a week by doing this. And so that's 50 positives a year, which is not a shabby rate of occultation detection. I was using one of Mark Bowie's 8-inch Skywatchers to do that. I've recently gone to a 16-inch Hubble optics telescope. My guess is I can probably double that pace and get about 5 to 10 occultations a month by doing that positives. What's interesting is that virtually all the events I'm doing don't appear in Occult Watcher because they're low-ranked events, and yet that actually means they're interesting events. Let me show you what I mean by that. So here's a typical Occult Watcher event from last night, actually, Aurora. Some of you tried this one. I see at least one positive. I had a 10 arc minute size cloud, I swear, that went inside the field of view at event time and then went away 10 seconds later. I just don't know how it happened. In any case, that's my no observation right there. But the nature of the event for Aurora, big, fat, low numbered asteroid, is that the size of the object is large relative to the uncertainties, right? The pink areas on the side. So this is one of those events that's worth chasing. You know where it's going to happen. You go to the shadow if you want, or you definitely plan it if the shadow comes to you. The events that I do on a nightly basis look more like this. Okay, so this is actually one of the AZ events where the AZ event feed is doing something very similar, very small asteroid relative to the uncertainty. There's no point in going to the center of the shadow because you don't know where that shadow is going to fall. The uncertainty is so large. However, if you get this event, I feel like you've accomplished something because you pinned down this uncertain object, right? The next time around, it's going to be a much higher rank, much more certain event. So this is the event I'm after. It's the event that naturally turns up when you make a bunch of predictions for the night using Occult 4. And to me, it's very productive. And maybe someone can tell me why I'm wrong to take this approach. Obviously, you've got to run your own predictions to do this. And Occult 4 is magic as far as I'm concerned. I cannot comprehend how, in this case, it's going to look through 141,000 asteroids for possible events. And it accomplishes that in a little over an hour or so. And so, Occult Watcher shows you just some high-ranked, filtered, selected events. With Occult 4, you see, I won't say everything that you can do, but you see, the potential events you have access to and many more than Occult Watcher is showing you. And these low rank ones are the interesting ones from my perspective. So for the telescope I have now, I filter for events brighter than 16th magnitude, and I look for all the events with greater than 5% probability. You do 20 of those statistically, you're going to get, a positive. And Usually things come up with much higher than 5%. Just for those of you who've run through Occult 4 or who haven't, the way I do this is I start with a very wide net. I set the object size down here to 3 kilometers. So that gives me my 141,000 candidates. I let it run on the entire set. They do a first pass with very wide parameters, 600 kilometer range of miss distance from my particular latitude and longitude. And then once I get a pre-selected list of a few hundred possible events from that, I go back to Occult 4, generate the horizons elements for those events, and then run a refined set of predictions, which are always in good agreement with the predictions that are out there in the real world. They're horizons based. And so in the end, that leads to a border 25 or so potential events I can select from at my site. Just one advertisement while I'm here. Occult 4 has the best finder charts I have ever used for anything. Okay, I look at these finder charts, I look at my picture of the field, and I immediately recognize where I am. And if I have the least bit of trouble, I've got this slider, thank you, to rotate the finder field to match the orientation. So finding the occultation star is just trivial. So I'll take $20 for the advertisement. Just kidding.
Can I offer a question or offer just a comment or two on the occult search?
Oh, absolutely. Go ahead.
Okay, if you want to go back to the page real quick, just
yeah, this
possible?
one.
Okay, right. So are you usually doing searches just over a couple days?
Yes, I never do more than 3 days.
Then you don't need to do a second pass. It won't make any difference.
I've noticed a big difference. Oh, I've tried that though, and the second pass is only on the ones that are found. But now I'm not using the new feature that does horizons for every object or every hit.
Yeah,
so
you should go ahead and you should probably do that. Now, actually, it probably should be. Oh, yeah, set automatically. I would think that would be your better option. Use horizons on each one, but okay.
Yeah, this is an older version. So actually, maybe later on, one of you can tell me who's using the new version. So I think this is fast because it pre-selects all the things I want to run horizons on. But maybe that's just happening in the main search whenever you get a hit. Anyway, I don't know. Bottom line.
Ben's comments with the new horizons one is very slow. So maybe you won't want to do that.
Okay.
Yeah. So maybe that's worthwhile then. In theory, given that you're just searching for low probability events, then yeah, that's an interesting question. Okay.
Yeah, I do want to make sure I've got the best prediction in the end, so I make sure to run the horizons.
Right, and then the key here is that you're searching. The thing that makes this all viable is that you're limiting it to events that pass within a specific location. If you cast the net wide, the number of events becomes too large. So that's a very key element.
That's right. It would never solve. And the issue I find is
it will, but it just takes forever.
Okay. Yeah, I have forever. So the issue is that when I go from the initial pass 1 predictions, which use the database that Occult 4 downloads into your computer, and then when I do the horizons update, the paths do shift a bit. So I want to cover enough miss distance so that after the horizons update, things move back into my neck of the woods. And so that's why I cast this wideish net. It might be the 600 kilometers is excessive. That's my miss distance right now. I can probably cut it down to 300. Yeah, it's the amount. Yeah, for the amount of time, it's just fine. So and the proof is in the pudding, as they say. So that's what's on the screen now. This is tonight's candidate list. It's not what I'm going to observe. It's what I have to select from. So my eye then goes to the higher probability events. My problem is I have a big fat tree at azimuth 180 degrees, and I can move left or right around the tree to get different access to azimuth. I have a wonderful southern horizon, and I'm at 2,500 meters, so I don't have a lot of extinction, but I got to get around this tree. So I literally, what I do, I just show you, a particular event that caught my eye, Bauero, which is a 36% event. Here's the azimuth. That's the first thing I look at, azimuth and altitude. Yeah, I can get there. I might have to put my telescope in a corner to get around that tree, but I can get to 142. It's doable, 15th magnitude. It's a long duration event. We're long for me is 1.7 seconds. And so I would pick that event off the list. Actually, I saw this event and it made me do one other query. I often go back to Occult Watcher Cloud and look at these events. That's how I verify that my tracks make sense, to make sure what I see on OWC is the same thing. And you go to Occult Watcher Cloud and you put in this event, and here's what you see. There's the path, and there's the uncertainty, the entire United States of America. Rank 2 event. Doesn't sound very interesting, does it? But OWC has an option to update the prediction, and this is obviously inconsistent with my prediction, which said I've got a pretty good chance. It's a 36%. It's got to be a tight uncertainty on the path. And sure enough, after update in Occult Watcher Cloud, this transcontinental event goes up to rank 86, and is nice tight uncertainty as Occult 4 predicted, which is expected because I think Occult Watcher Cloud uses Horizons elements to get the path, but for some reason doesn't incorporate the right uncertainties, or it has excessive uncertainties.
The difference is when Occult Watcher, it's sort of a two-phase approach with Occult Watcher Cloud. It does an initial search based on a set of bulk elements, which are not at all fine-tuned to the date of the event. It uses that to kind of identify events. Once an event has been tagged by any tag, or in the case of this request for update, then it actually computes a more accurate prediction based on elements which are tied to the actual event time frame. And so you get a much more accurate idea of the uncertainty at that time. So until something's been tagged, it's sort of a lower quality prediction. Once it's been tagged, then it gets bumped up, and you get the most accurate prediction you can out of Horizons.
Great. While I was putting this talk together, I actually did a personal tag on this one. So if anyone wants to observe it, given where it goes tonight, it's a pretty broad event. I'll be out here on my back porch, and it's going to be clear. All right. So
can I jump in here?
Of course you can.
In terms of your problem with a bloody big tree in your yard, there's probably a feature in the Occult which might make some value to it. Let me share my, can you stop sharing your screen? Let me share my screen.
Sure. I'm down to the last couple of slides, so I could just rocket through those and then let you start screen sharing.
It might be, it's only a minute, but you might be very interested in this.
Okay. Hold on a second. I just stopped sharing. There you go. That's why people might learn something.
Right, on the screen here, this is the list and display form, which you're used to. And over here, you're listing events visible from. There's a little box here about visible from, and there's a bit there greater than horizon. Now, this is probably a feature you haven't noticed, but in here, there is an option here. Set the elevation of the local horizon. And there you have
different directions. Yeah.
Different directions and altitudes. If you set that in, set those parameters for your local horizon, then when you're doing your filtering, select visible from and then select your local horizon. And then that will filter the events according to your horizon.
Got it. Yes. And the only tricky part is that it's more of a puzzle for me because I have about 20 meters of left, right, east-west range where I can place my telescope. So that horizon map moves around for me depending on where I put the telescope. And so that's why it's more of an intellectual exercise. Just look at the whole set of azimuths and altitudes and probabilities, and then try to do some optimization of, well, if I put the telescope over here, I'll be able to get to these events. If I put the telescope over there, I'll be able to get to this other set of events. And which ones do I want to do?
Oh, okay. Well, I mean, you do what you need, but I thought you could filter out a whole heap by that of things which will be. Thing there, and my guess is you wouldn't have noticed that thing before.
Yeah, I was vaguely aware it might have been there, but I wasn't sure that
you just need another telescope, Mike.
I could use 3 or 4, but I'm happy with the one I have. It's just I got to put it in the right place every night. It's a balancing act. Let me just finish up here. It'll only take a second if I could find my controls here and go back to the current slide. So anyway, that was the whole list for the night. As soon as I finish talking, I'll try to pare that down. Here was what survived last night's selection. So I started with about 25, came up with these 10 events, observed them all. I haven't had a chance to reduce them yet, but you see, varying probabilities for events. And 94 Aurora was the one where the cloud decided to come, just at the wrong time. But it's a pretty effective and fun process. So typically 6 to 12 events survive. Star shows up in the center of every event. Sometimes autofocus works, sometimes it doesn't. Most of the time, the focus is still pretty close. So in the interest of time, let me wrap up here, offer my email, because if anybody's interested in anything I talked about and it wasn't clear, or there is some question you have, please just contact me. But I've been having fun with this. I think it's very effective. I'm at the point now, set it up, turn it on, start the script, go to sleep, wake up in the morning and see what you got. And I think that's a nice way to work. That's it. Thank you.
Well, I
Thank you
just have
very much.
one comment and one question. The comment is, why does the scripting language remind me so much of COBOL?
Probably, I'm not going to guess, but
That was horrible. But anyway, do you have anything at the end of the script to say pointed at some place where it won't be pointing east when the sun comes up?
absolutely. I don't know if I'm still screen sharing, so I can probably just bring up a script to show you how everything wraps up at the end of the night. I mean, there's two things. I know where my last target is, and the tracking turns off then. So that is one approach. But let me see. Here is a script. There we go. You're still seeing that, right? Go down to the very end, stop here. So that's the last event, event number 10. Warm up the cooler, turn off the mount tracking, and then if where it was pointed is a little scary, I go to a fixed altitude and azimuth where I know the sun's not going to be a problem for me. One problem I'm having, I would just push the park button. There's a park command. You can park the telescope and unpark the telescope in the script. With the controller I'm using now, sometimes the telescope decides to go a full 360 degrees or more to get to the park position. And since I'm using hardwired 120 volt AC here in the US, I've got cords and I have cable wrap issues. I'm not carrying batteries that can run all night. And so I'm a little afraid to park it. But yes, absolutely, you can point it where you want it. Definitely turn the tracking off. One of the scary parts is if the script fails when you're tracking in the middle of the night, you get kicked out by an error, you keep tracking. And so your telescope limits are going to have to kick in to keep the tracking from being a problem.
Thank you.
The chat, Jerry Bardaker asked about high RUWE, if you do any filtering for that.
I don't. Ultimately, if I did this for a year and really was careful about the statistics, it would put the uncertainties to the test. It would put the RUWE to the test. I'll tell you when it comes into play. And you see Aurora had a crappy RUWE last night. I know someone got a positive, but it's a big asteroid. And this is the list after filtering. But a lot of times I'll have 2 events or even 3 events that happen within a minute or 2 of one another. Then I have to down select, and RUWE is a great way to kick out an event when there's a time conflict. I can easily do events, 6 or 7 minutes apart. Last night I did like 4 events in 25 minutes. They're all bunched together. You can see them up here at the top somewhere. So if you cleverly gate those wait statements, you can stack up events to happen real fast, and you skip the focus. That saves a couple of minutes. You could probably do events 3 or 4 minutes apart with this.
Sounds great.
Is Venable back to run the show? I know he disappeared. I hope that wasn't a hard crash.
I think we're good. I think that was Roger. So yes, I think.
That is
Oh,
I.
good. There you are.
All right. Well,